if you just do it, it'll turn out okay. It'll really be okay if you could go hit that like button on Facebook or YouTube, where we're streaming right now. My guest today, her name's Maddie, and she has a YouTube channel. She does other stuff too.
I do a lot of things, but yes, I have a YouTube channel. It is Science Side Up. We talk about happy science things over there. I do a lot of stuff with climate and weather because that's what I'm in grad school for. So that's what I think about all the time.
So are you good? Your master's or your doctorate?
I am. I'm in the PhD program now.
So you'll be Dr. Science pretty soon.
Dr. Science, yes, that's my supervillain name. No one can take it. Soon, that is who I will be.
Right. So you mentioned that, like, right before you here, I was watching. I was watching Dapper's stream, and they were reviewing the Thesis of Kent.
Oh yes, it makes me very angry.
Is your thesis going to begin with "Hi, my name is Maddie"?
No, it won't. I haven't started writing my dissertation yet because that's a task, and I'm doing my general exam here in another month or so, which is a very fun bit of like, university approved academic hazing that all PhD students have to go through. It's the kind of the go, no go. You have to take this test and prove that you've learned things. Anyway, and then you get the privilege of writing your dissertation. And things most dissertations have an abstract. That's a thing that exists. Some record of some record of a bit of research that you did, right? So if it's a PhD, a Doctor of Philosophy, as opposed to like a different professional degree, right? Like if you go to law school, you get a Doctor of Jurisprudence, I think is it. If you go to medical school, you get a Doctor of Medicine, right? So those are like teaching you specific job skills, and they have their own ways of validating that you learned the things you're supposed to learn. But what a PhD is like universally teaching you to do is be a researcher, right? So like if you're going to call it a PhD, the expectation is that you can do like independent research, and that's not just like a literature review, right? That's not just what is like everything that other people are saying, but then also propose a novel question to the field, developed ways to test that, and then test it, detailing your methods so that somebody else can repeat it, and then drawing whatever conclusions and putting forth your like, so this is therefore what I think is going on. And really a dissertation should hold 3 unique experiments, right? It should have, the general rule of thumb is that like a master's thesis should be worth 1 paper, and a PhD dissertation should be worth 3 papers. Now, in a thesis and a dissertation, you do include the things you tried that didn't work. So that's like that. You don't put that in the paper, but that tends to go in your dissertation, which is what you spend most of your time doing, is trying things that then amount to nothing.
So how many times have you failed yet? 300, 400 yet?
How many times have I what? Sorry.
Have you failed yet on your project?
Gosh, so many. So many. It's very well. So the question that is at the heart of my PhD research is so I study Arctic weather, and specifically how the atmosphere and the ocean interact with sea ice. So sea ice is not glaciers, right? So glaciers is what's in Greenland. That's all freshwater ice. I study frozen seawater. And like the goal there, the ultimate goal is like in the summer, you have a good amount of melt so that we have like shipping lanes through the Arctic that, weren't there 30 years ago, but are there in the summers now. And so we want to be able to better forecast sea ice, when these sea lanes are going to be open, and then understand how those changes would affect the weather so that you can have tell the ship captain who drew the short straw and is having to traverse the Arctic. I want to be able to tell them, like, I want to help keep them safe, right? That's sort of the ultimate goal. But I'm specifically looking at like these short-term interactions between the atmosphere and the sea ice. And so the big question is, like, physically, what actually causes that sea ice loss? And that might seem like a simple question, but remember that, like, people don't live on the ice. We don't have radars or cameras, right? I get a satellite picture twice a day, and that's it. That's all the data I get.
Hey, so that's good news. This is good news for those 16th century explorers looking for a passage over North America. They can go for Asia for spices because they can't get there because of the ice. Now they can.
Yeah, it turns out climate change opened a Northwest Passage.
They're just a few hundred years early.
Exactly. Yeah. So the like things I have done and tried and failed is like, oh, okay, well, does this data set capture what I need to know? No. Great. Can I look at, so trying to figure out what data is actually available, short of like, I don't know, finding funding to go live there for like 6 months and watch some ice. But even that only tells you about what's going on at that place, right? So just figuring out the best like statistical method and other stuff. But I have failed miserably at learning how to run climate models. It turns out I'm very bad at that. But that's okay. Other people are good at it, and they'll help me out. I'll do their statistics for them. We'll trade some skills back and forth.
So does your research have anything to do with the different ice ages going in our past and possibly future?
So not really. I really look at short time scale processes.
Okay.
So what you're talking about is called paleoclimate, which is a super, super, super cool field. Looking at like what was Earth's climate like 5,000 years ago or something like that. But my work will help us with improving climate models to ask what's going to be going on in 100 to 200 years.
Wait, are you saying that all science isn't the same? You can't say one thing and be knowledgeable in everything in all of science?
It's so true. Yeah, just because, and I'm actually kind of weird, right? I have a very diverse science background. I've popped around to several different fields. But, I'm the only thing I'm going to speak as an expert in is short-term sea ice loss processes in the Arctic, because that's what I think about all day, every day. But even if we're going to talk about like what was the Arctic like 50 years ago, I'm still going to default to like the experts in the field, because I don't think about that. I only think about the Arctic since it's been affected by climate change.
How long has that been? I thought it would be like the last 100 years. That's
so that's true. Okay, so we've only been able to. I only think about the Arctic since the start of the satellite era. Okay. So from 1979 forward, because before that we don't have records of the Arctic other than like 3 stations from like Russia and our Barrow, Alaska station, and that's like hardly even in the Arctic Circle, right?
Okay. Well, Scott says hi.
Hi, Scott. How are you?
And then says John Hopkins COVID lockdown thing going through the news was written by economists.
Economists. Yeah, listen, it's dangerous to talk outside your field. And if you're going to do it, you need to be very, very, very upfront that this is not my field, but I have a basic understanding of it. That's what I do whenever I talk about radiocarbon dating or any type of radiometric dating, which is one of my favorite things to chat about when I'm doing my favorite pseudoscience debunking things. Which is about what half my YouTube channel is dedicated to.
And he got mad.
That's upsetting. Yeah.
So, hey, you said you do like you look at sea ice.
Mm-hmm.
Can you get like ice cores from that, like you can from other ice, like ice core samples? I've seen.
Yeah, so kind of. It's not as long a record, And it's getting harder and harder. So sea ice has a seasonal cycle, right? Some of it melts in the summer and then refreezes in the winter. But you do have older ice packs. But that old ice is probably like, it's not going to be like thousands of years old like you get in glaciers. Like decades old would be kind of what you get.
Right. So is saltwater ice different from freshwater ice?
Yeah, so there's some different processes that you have to consider. One is you get this like brine rejection. So as the seawater freezes, you start to reject the salt out of the bottom of it. So that ends up making the top layer of the ocean like really salty and kind of dense, which can start to get some start inducing some ocean circulation. It also has a different freezing point. So it has different freezing and melting points than freshwater ice. So that's a thing to consider. But those are just some kind of nuances. It is ice, it's ice floating on top of the ocean.
So
the reason that I specifically differentiate between saltwater ice and freshwater ice when I'm talking, especially like outside of the field, is when sea ice is like the ice that's in the glass of water, right? Yeah. When it melts, it doesn't change sea level, right? Whereas when freshwater ice melts, that's adding water to the glass.
And plus, plus that's like also do something with the density or something like that. Like whatever that word is, the fresh saltwater combination mixes up or something.
Yeah, that also is going to change the salinity of the water.
That's the word.
Which certain wildlife are really, really sensitive to. So changing that salinity, especially like locally, is actually already having a lot of devastating effects on local wildlife. Areas along like the southern coast of Alaska and along the coast of the Pacific Northwest, they're really seeing some of those effects right now.
What's up with this doomsday ice sheet from Antarctica?
Okay, so left over from the last ice age, there are two main ice sheets left on planet Earth, right? One is Greenland and the other is Antarctica. So Greenland and Antarctica are both almost completely covered in an ice sheet. So that's freshwater ice that's been there for thousands of years. When those melt and all of that water gets added to the oceans, that's going to cause like the largest, that's what's, if you've ever seen a map of like what climate change will do to sea levels and you're like, holy crap, Florida's gone, right? That is when that Antarctic sea ice sheet, especially when that goes, that's going to be a problem.
All right, so everyone, you want to go to Disney World, you better go now.
Yeah. No, is that going to happen tomorrow? No. Is it going to happen next year? Probably not. Is that going to happen in the next 100 years? Yes. Right.
Inch by inch.
Yeah. It's one of those things that is, I know what most people want is for me to be able to say, in the year 2045 at 3 p.m. on a Tuesday in April, that's when the dam's going to break and everything's
here, folks.
Right. Yeah. So I know that that's what people want out of like a climate model, but that's not really the type of question a climate model can ask and answer. It's we're looking at, I think more about when is all of the sea ice going to be gone in the Arctic in the summers. Well, it's not going to be this year, and it's probably not going to be next year. It'll happen by 2100, and it probably will happen well before 2100. But I'm not really sure. I don't really know how to tell you more specific than that.
Just leave your notes for your grandkids.
Yeah.
We die. Okay, Sally. This is your research. This is your research now. This is what happened 100 years ago. It's up to you now.
Exactly. And so one of the main goals with climate models is narrowing those time bands, right? Like being more specific with our predictions, because that's very hard to do.
Because you never know, people might rise up and reduce climate change a bit in the next 100 years.
Exactly. And actually the largest bit of uncertainty in climate models is future human behavior. Everything else we can model real well, right? Like Earth systems, orbital mechanics, that's all really easy. Human behavior is very hard to predict.
It's hard to predict in the present day.
Exactly. So like, you know, if we actually go carbon neutral by 2030 and carbon negative by 2050, which are some of the goals that have been set out, at least by the Biden administration, and if like, well, do other major players get on board with those goals, right? Then the climate models look not as scary, you know. If we do nothing, or if we keep pumping out more and more carbon, that looks scary. So we have time to fix it, you know. We can, and that's not to say like we're certainly already feeling the effects of it, right? But we have time. And yes, absolutely, I'm such a stan for nuclear power. I think it's a great idea. More nuclear power, please.
So, okay, how did you pick your name for your channel?
Science Side Up. So one, I love play on words, and so that's the play on sunny side up. And I also wanted, so I this is my philosophy on life, the universe, and everything. I think that a lot of people have, even if they like think science is cool, or maybe they like loved astronomy as a kid, you know, like that kind of stuff. I think so many people get kind of like scared away from the field, right? Maybe they take a math class, you know, maybe it was calculus and you were trying to get through calculus and it just wasn't clicking for you at that time in your life because of like with that teacher or whatever have you. And so I think a lot of people get like intimidated by science. Or it's like, you know, old dudes in lab coats with gray beards descending from their tower to tell you how the world works. And it's this whole rigmarole, right?
So you mean our hallowed science masters of the world?
Yeah. So one of the main goals of my channel is to make you know, good information easily accessible, right? Because I think one of the things that helps misinformation spread is that misinformation is often more accessible than correct information. And so I wanted my channel to be like happy and low key and not intimidating, you know. So it's just me in my garage with my chalkboard and my unicorn hoodie, just to try to make it as approachable as possible.
So, I go on. Hey, I like my brand new grand piano.
Love it. It's beautiful.
Thanks.
Yeah. How do you like my emotional support Batman?
You know Batman?
Yeah. No, that emotional support Batman comes down. He's only come down from the shelf like once. I was on Dapper Dino's channel. We were debunking some young Earth creationists. I think it was Matt Powell. And my brain was exploding. It was like leaking out of my ears because of the amount of just bad, just not good that was coming through my speakers. So he's always on. Emotional support Batman is always on standby.
Hey, well, speaking of YACs, can your does your research have anything against them? Like, can your,
I mean,
or not? Since it's more local, since this is more of a local time period.
I mean, I guess like what I do day to day doesn't have a direct. No YEC person is asking themselves how sea ice works, right? No one is. For me, one of the places where I do feel that like my field does intersect with YEC is you often hear like YEC organizations when they talk about climate change, they are very dismissive of it. And it's usually because uh, it's usually like rooted in that belief that the earth is only 6,000 years old, that humans like or even that like God wouldn't let something catastrophic happen. And so it really bothers. It's such a strange point of view. And somehow like because Earth is young, the climate can change quickly and that's not a problem, right? Which is absolutely not true. Like the Earth is not young. Also, climate changing quickly is terrifying. So for example, the last ice age, right, which was about 60,000 years ago, ended about 60,000 years ago. Average Earth temperature was 4 degrees Celsius colder than what it is right now, right? So that means, right, that the Earth warmed 4 degrees in 60,000 years. Well, in my lifetime, the Earth has warmed 1.5 degrees, right?
That's pretty fast.
Almost half as much, right? And so that's terrifying. So just think about when people say like, oh, 1 or 2 degrees is a lot when you're talking about a global average.
Like,
right.
We're just fast now. Fast internet, fast melting. We're fast people.
Yeah. But okay, so my undergrad degree is I double majored in math and earth, atmospheric, and planetary sciences. And mostly what I did was like geophysics kind of stuff. So I have a like baseline layperson's understanding of geophysical processes, including things like radiometric dating, right? How the Earth formed, how the solar system formed, those types of things. Less so with like more astrophysics. So like I actually have more of a salt. Like I could rattle off right now how the solar system formed and how we know it formed that way. I'd have to like do some Googling to talk coherently about Big Bang, other than like what you can get out of a Neil deGrasse Tyson talk. So I have that, and then I also spent 4 years in the Navy as an instructor for the Naval Nuclear Power School. And so I have a weird amount of knowledge about nuclear reactors. And there's so many things about like about those like that I just view as basic knowledge that is completely incompatible with young Earth creationism. And so it just blows my mind that people actually think this. So just for example, our sun, right? Our sun is 4.5 billion years old. It's about halfway through its lifetime. And like it's also right now burning as hot as it will ever burn. Right.
It's still on the hydrogen to helium phase of its life.
Yeah. And like you can't make a star 6,000 years ago that has the properties of our sun, right? That burns the way it's currently burning, right? That we can tell from the temperature and things like that. Temperature and intensity of the energy coming out and the color of the light, right? All that fun stuff. And it'll only be 6,000 years old, not without needing a miracle. You can't have magnetic bands indicating a change in the Earth's magnetic field across the ocean floor, right? That indicates that the ocean floors are about 200 million years old. You can't make that, right? You can't make that in 6,000 years. And so there's so many things that are just like, in my mind, like fun facts I remember from undergrad that cannot be explained by young Earth creationism. And frankly, by most folks in young Earth creationism, are not all, but most folks in that camp are so scientifically illiterate that they don't even know these things exist or are problems. Yeah. And that's also very frustrating to me. And I don't want to like condemn anyone for not knowing things, you know? So I want to put information out that's like useful, but I also refuse to take any of their arguments seriously, right? Like I just can't, because it's so nonsensical.
Yeah, like Venerable Beat said, he didn't know about younger creationists till later. I knew about them when I was going to church and stuff, but what I didn't know about till much recently that there were still flat earthers around.
Yeah. The rise of flat eartherism blows my mind. And I knew younger creationists. I grew up I went to high school at a pretty conservative Christian high school. For me, there I received a really great education. It was very like science focused, and you know, for me that was a very positive experience. But it wasn't a young Earth creationist school, though there were people there who were more conservative than the school, if that makes sense, right? So like we just skipped over human evolution. That was just not a thing we talked about in biology class because someone's mom was going to complain.
Yeah. For me, in science, my interest in science was that I loved growing up. I loved the food chains of life.
That's awesome.
Like how far, what eats what, and how far can it go?
Yeah, I remember a really great Bill Nye the Science Guy episode about like food webs, where he had a whole like jungle gym like tied together with yarn of connecting different animals that I thought was really cool.
And all begins with the sun.
Mm-hmm.
Also, science. Another thing that amazed me in science when I learned it was that our sun is one of the on the smaller scales of stars.
Yeah.
Like you think that are so big compared to the sun. I mean, reverse that. I mean, that sun's so big, and all of a sudden you look out in space, like, nope, it's a baby.
Well, another thing to remember, right, is in order to have out of the Big Bang, we get 99.9% hydrogen and a little bit of helium. So the very first, and the only way to get heavier elements is going to be stellar fusion, right? So in order for you and I to exist with this carbon, right, you have to have stars that were just hydrogen burning, right, that lived and died and exploded and sent these, and as that happened, they made heavier elements. And sent those out to now be incorporated into new stars, and then also into other things, right? Into the protoplanetary disk that would eventually become our solar system. So like, you know, if I know the younger creationist answer is like, well, God made all of the elements, but that's just to me, that's such a cop-out, right? Because that's not a natural process.
Yeah.
And if God bothered to make natural laws, why wouldn't he use them?
Yeah, and I know we're going off of your, I know we're going a little bit off of your expert.
We are going outside my expertise.
Yeah, but I think our star is like the second or third generation star, isn't it?
I don't know that off the top of my head. That I'd have to look up.
Well, that's why I'm not positive, but I think I read that before. Since it had to be, because since there's already iron and stuff in our nebula, there have to be at least a few generations.
Yeah, there's already iron, there's already uranium, right? We've had stars that went supernova before our solar system could even be a thought. So third or fourth generation sounds right, but again, I'd have to look it up, so I'm not going to commit to an answer.
Yeah, I wasn't there to watch the live stream of it happen.
Gotcha.
So do you since you're already in your PhD thesis level stage, are you teaching any class? Are you a teacher too, or?
I sometimes teach. I'm sometimes just listed as a research assistant. So, yeah, I love teaching. but I don't have a lot of time to do it. So I'm spending a lot of my time doing research.
Yeah, I appreciate that. I wanted to be a history teacher when I was younger, but I did terrible in college, so I couldn't make it. Was it? I don't know. Was the study grind or the transportation there? I just did terrible in college, so I appreciate people that stuck it out and made it.
Yeah, I mean, college isn't for everyone. I'm incredibly lucky that I've had like the opportunity and inclination to spend my whole adult life doing science. But one of the things I did do was I took a break from school for 4 years to be in the Navy and teach at a schoolhouse. But that let me, that made grad school actually a lot easier. I got to start grad school a little older. I got to spend 4 years in a pretty well-paying job, so I had built up some savings before I started grad school.
Did you teach your fellow Navy people about the ice?
Sorry, what?
Did you teach your fellow Navy people about the sea ice?
No, I taught Navy people how nuclear reactors work. I taught at the school where all guys that are gonna go be on submarines or carriers and operate the nuclear reactors, right? They come to that school that I was at for 4 years, and I taught them what fission was, so that they knew what that was before they graduated. That was my job.
Fission. That's where atoms break apart instead of coming together.
Correct. Yeah.
So, So I remember before the pandemic, I was talking with Erica, got to Gibbon, and she wanted to do a field research trip. Of course, it got canceled because of the pandemic. Have you ever been on a field research with your area expertise?
No, my research trip keeps getting canceled. I've been supposed to get to go up to the Arctic and ride in some planes that are going to fly through a specific type of storm up there that I'm really interested in. And that's been canceled the last 3 years in a row because of restrictions with COVID. So I have gotten to do the field work I have gotten to do. So I'm at the University of Oklahoma. Our thing that the university is sort of known for is tornado research and severe weather, right? That's what most people out here do. Because, hey, if you live in Oklahoma, your weather tries to kill you all the time. So we want to know more about that kind of weather so that we can give people more and more heads up. So when we have a big field campaign to go study tornadoes and severe weather, there's kind of an all call, and anybody that wants to help out can. So I got to do that in the summer of 2019, so right before the pandemic. And got to go out in the field for a couple of weeks, hang out with the radar truck, follow storms closely for research purposes. We weren't supposed to say the phrase storm chase, but we followed storms closely for research purposes. But honestly, with the radar trucks cost millions of dollars, right? You don't want that in the tornado. That's a terrible place for it. You want to park it 20 miles southeast of the tornado and let it pass to the northeast of you, right? Pass on that trajectory. So that's what we did.
Too bad that would be a very good frontline detail expertise. Get a satellite in the tornado. Here you go. Here comes the data.
Yeah, exactly.
So hit anybody's house.
Exactly. That's what you want, right? One, you don't want tornadoes to happen, but they are an inevitability in a lot of parts of the country. So we want to better understand them so we can give people more warnings in the forecast, more lead time. That's the ultimate goal.
Yeah, I know hurricanes. I think I read this somewhere before that hurricanes are affected by climate change. What about tornadoes? Are they the same?
So tornadoes is actually pretty hard to say. So things that are hard to say is a warming planet going to cause more intense tornadoes and or more frequent tornadoes? That's an I don't know. That's
Okay.
some studies say yes, some studies say no, right? What you can see though is uh, uh, we're getting tornadoes across larger areas. So like
Okay.
places that didn't used to see them are starting to see them more often, right? So I think and this is a thing that I would want to double check, but I think that it's more that where tornadoes happen, they're able to happen in more places as opposed to making more intense storms or more frequent storms.
Yeah, we had a big tornado here like 3 years ago.
Yeah,
in 2019 that destroyed half of the community downtown.
Yeah. Well, and what's really hard is so like out here in Oklahoma, just today, every Saturday at noon, our tornado sirens test, right? The dogs howl at it for the minutes that it's on. Most public buildings have storm shelters. Like a shopping mall has a designated storm shelter. New built homes have tornado shelters built in. There are public shelters for folks that like live in, say, like a trailer park or an apartment building. So like public shelters exist.
Does your house have a storm shelter built in?
My house does not, but we have. If you can't actually get underground, the best thing to do is to get on the first floor. And my house is a 1-story house, but the most interior room and a room without windows. So in reality, the thing that's most likely going to so like the probability of a tornado hitting your house is pretty low, but a tornado throwing shrapnel through your house, right? That's much higher. So that's probably the thing that's going to cause you harm. So most central room in a windowless room in your house, get in there, bring your pets in there, let your friends that live in apartment buildings come huddle with their cats. But my point there is that like I've been taught tornado because I grew up in Oklahoma. So I've been taught tornado safety since I was in kindergarten.
Yeah, we had tornado drills too in Ohio. I live in Ohio. In the valley area, so we had lots of tornado drills too.
Gotcha.
We all went to the bathroom in the school.
Yeah. This past tornado season, there were several tornadoes that hit New Jersey. And a place like New Jersey they're not expecting it. They don't have the infrastructure and they don't have the public awareness. And so like, that's hard because then folks don't necessarily know what to do. Right. That's another thing you see in the Southeast, like in Alabama. Tornadoes there, while no more frequent or no stronger than they are out in the plains, are overall more deadly. And the thought there is that's mostly rooted in infrastructure.
It kind of be like if say Oklahoma or Kansas got hit by a hurricane.
Mm-hmm. That would be weird. We would not know what to do.
But yeah, you said tornadoes, but you could. Like hurricanes are more closely connected to climate change, you said?
Yes. So current climate change models suggest that with a warming planet, hurricanes it's not that we'll get more storms, but the storms that we do get will be stronger. And so that means a stronger storm is a longer lived storm. And so that makes it actually more likely to hit land, right? Because it's more likely to live long enough to make landfall. And then when it does make landfall, it's more devastating.
So if it's big enough to hit Oklahoma, that's really devastating.
Right. It'd be very difficult for a hurricane to hit Oklahoma. With a hurricane, warm ocean water, think of that as its battery.
Yeah.
Right. So the second the hurricane moves over land, it's cut off from its power source. So it's just discharging. So like when hurricanes hit, say like Houston or the Texas Gulf Coast, we in Oklahoma days later get a little bit of rain, even if it's like a Cat 5.
I know that thing. Even up in Ohio, we had hurricanes like 2008, so down in Florida, I think.
Yeah.
I can't remember the date, but for a few days later, there was a terrible windstorm up here.
Mm-hmm. Yeah, so you'll get the remnants, but it's not nearly as strong. And it's not going to cause the flooding because the most dangerous thing of any storm is always flooding. And so, but not being on the coast. So one thing that you get with hurricanes, right, is the winds and just the low pressure of the storm pulls ocean water up onto land. And then it's also raining like crazy, right? So you have both of those things that are going to cause flooding.
So why are they not called hurricanes in the Pacific? They're called something else, aren't they?
Typhoons.
Yes.
That's just different countries and different languages. They're the same storm.
So if it's the Pacific's a typhoon, if it's the Atlantic's a hurricane. Mm-hmm. They've never really understood that name thing.
It's just like the culture that named it. Okay. If that makes sense.
And what about what's that word? The spinning direction?
Coriolis?
Yeah.
Okay.
Where like the south, it spins one way. Mm-hmm. How's that? What's that about?
Okay. So that has to do with the fact that the Earth is spinning, right?
Yes.
Okay, so the Earth is spinning. So I've got here, the closest sphere I have to me is this ball of yarn. So we'll make do. So this ball of yarn is spinning, right?
Okay.
And let's say I'm at the equator, right? I'm at the equator and I'm spinning. So even if I'm not moving, right? If I'm not moving relative to the surface, I am moving at the speed that the ball is rotating, right? I'm not going to feel that because I am on the spinning ball and I am very small compared to it. But to an outside observer, right, like an alien watching from space, oh yeah, they're moving this fast, right? Now imagine someone who is just right up here, right? A little farther up. Okay. So this circle, right? If I cut the top off of this ball of yarn, this circle is smaller than the equator, right? Okay, cool. So this person traveling like that, right, is with the rotating sphere, is traveling a shorter distance in the same amount of time as a person at the equator. Okay. Cool. So now we're going to think about a large mass of air, right? So our atmosphere is like stuck to the Earth with friction and gravity. So it's moving with it. But if I have a parcel of air here that starts to move north, well, I'm going faster than the air here. So if I start to go north, I'm actually going to move up and to the right. Right? I'm going to curve like that because it's conservation of angular momentum, but it's just I'm traveling faster. Okay. So I'm going to be ahead of them. So that's all Coriolis is. That force, the thing that causes the air parcel to curve is the Coriolis force. And so if I'm going down in the southern hemisphere, right, it's different because I'm going to go to my left, right? So in the southern hemisphere, it displaces you to your left, and the northern hemisphere, it displaces you towards your right. Now, something has to be pretty darn big in order for it to feel that effect. So it has to be about the size of a hurricane. That's about 1,000 kilometers across. Anything smaller than that, and it's like you and I'm not going to randomly get displaced to the right if I start walking north, right? Mm-hmm. I am too small compared to the Earth to be affected by it. This is the thing that drives flat earthers insane, by the way, because they really struggle with thinking about scales like that, about what that different forces affect different things at different scales. But
yeah,
that's
so,
what, yeah.
Okay. So you said your research that hardly affects YACs a little bit. What about flat earthers? Does that affect them at all?
I mean, like, my research, no, but like if the Earth is flat, hurricanes can't exist. So I don't know. I don't and I once on Modern Day Debate, I debated Nathan Thompson, who's a flat earther, and I won't say anything else about him. And I was really trying to hammer home. I just want to talk about like hurricanes in the atmosphere, because that's if the Earth is flat. So hurricanes in the northern hemisphere are going to spin counterclockwise because of that Coriolis, and hurricanes in the southern hemisphere spin clockwise because of Coriolis. And if the Earth is flat and not rotating, then there's no reason for that, you know? And there's also no way for them to form, because you get the rotation of the hurricane from Coriolis.
Yeah.
So I was really trying to get him to explain how do hurricanes work if the Earth is flat.
The closer you are to the ice wall, the spin in the opposite direction, obviously.
Clearly, yeah. So I never really got an answer from him. He just kept saying the word electromagnetic wake. And I was like, that's not, I don't see how that's going to affect a hurricane. Can you explain
that? Is that a thing even?
No, not at, I mean, like an electromagnetic wake in a scale, in like a micro scale, is I think potentially a thing in like E&M theory. But it's not a thing in weather. A hurricane, turns out, does not have a magnetic charge, right? And then the other thing that drove me nuts was that I was trying to get him to explain that I couldn't get him to explain was okay, so a column of air, right? Obviously, the density of that air goes down as you go up, right? And I asked him, why is that? And he said, because that's like opposite of what it would be if the flat Earth model was a thing, right? Because the warmest place is at the surface, right? And then the coldest place is far away from the surface. So if it was just governed by temperature, then you would have the least dense air at the surface and the most dense air aloft. But obviously that's not the case, because gravity is more important than temperature. And so then he told me it was because it was density sorted. So you had the heaviest elements at the bottom and like the lightest elements at top. And I was like, but that's not what we observe. We observe is that at the surface of the Earth, it's 72% nitrogen and 28% oxygen and other elements. And then at the top of Mount Everest, it's still 71% nitrogen and 28% oxygen. And he didn't like that either, and just sort of ignored that. And then he just yelled the periodic table at me. So
like that'd be a fun game. Periodic table, go. I mean,
yeah,
you name. But yeah, I did an episode on that last year, 2 years ago now. But instead of focusing on the Earth isn't flat as a globe, my episode was on how we know that we're not, the sun isn't going around us, we're going around the sun.
Okay. Yeah.
Because people always talk about that. People never talk about the geocentricness of how that flat Earth works. Like,
yeah.
So I did a little different subject.
Yeah, and we've known that the Earth is round and a sphere, and that we go around the sun for several thousand years. Like,
well, I don't know about the going around the sun part, but definitely the Earth's been not flat for a long time.
Yeah.
How do flippers explain earthquakes and volcanoes?
Yeah, that's a great question, because that's another thing that you can point out is you can go get yourself most seismic data. Most like geoscience data is free and available to the public if you know where to look, right? So if you know when and where this is actually how scientists in the early 1900s mapped the center of the Earth, is they would get seismic data. And we know a hurricane, we were just talking about hurricanes. We know an earthquake happened here. And so that sends P and S waves through the whole Earth. And the timing of when those waves arrive, those different types of wave arise at different places, and the fact that there's going to be an S wave shadow directly across from where the earthquake started and then out for several angles, that tells you that we have a liquid outer core, because shear waves. Yeah, shear waves can't propagate through a liquid, but pressure waves can. Right? So like there's so much data, and it's just like laws of optics, right? It's nothing more complicated than anything you can test with like a magnifying glass.
Now
you can map out the interior of the Earth.
Can your research affect any of this stuff like tornadoes, hurricanes, or earthquake, flat earthers? Your research in
my research? Nah, my research doesn't have anything to do with this. It's so niche, right? PhD dissertation. I'm like one of 2 people on planet Earth that care about what I'm researching, right? That's
do you have any published papers yet?
Not yet. I've got one that is with like it's been with my like co-author forever, and I'm just waiting for them to give the thumbs up, and then we can send it out. And then once that one's accepted, I've got another one already written and ready to go for my master's work.
Cool. So
yeah.
So you're technically you're not in any journals yet, but you're hoping to be pretty soon.
Hoping to be within the year. Yeah.
Now I'm talking about all this anti-science stuff. I mean, flat earthers and young creationists are one thing. They're stupid, in my opinion, but of course, their stupidity also leads to another stupidity. I don't know if you dealt with in Oklahoma or not, and that's the Vaxxers stupidity.
Yeah. So if you were unaware, Oklahoma was recently awarded the most dangerous state to live in during the pandemic. Yay! So there's a lot of anti-vax folks out here. Luckily, like not amongst my peer group, not in my family, not like the university. In general, the university students are pretty chill about getting vaccines because I live in the university town,
Yeah.
And so it's a little better here. But yeah, anti-vaxxers are, I don't get it. I don't get it.
Like I said, there's stupid science deniers like flat Earth and young creationists, whatever. Then there's the ones that are dangerous science deniers.
Yeah. So to me, the difference is like I think all science denialism is to some degree dangerous because it leaves you, the individual, open to being taken advantage of, frankly. Yeah. And I don't want people to be taken advantage of, right? That's not a good thing. I don't wish that on anyone. But the anti-vaxxers have the, like, their choices aren't just affecting them, they're affecting their community. And I don't like that. And I'm not like, I'm not ever going to say like everyone shall be vaccinated, right? But I do think if you choose not to be vaccinated, and that's if you choose not to be vaccinated, because there are some folks who legitimately, because they're immunocompromised, cannot.
I understand. Right? I understand that part, and that's why we all need to get vaccinated to help them out too.
Exactly, to help the like those who are like immunocompromised, to help the elderly, to help children who aren't old enough to be vaccinated yet. Right. This is why that's a thing. So I do think it's appropriate that if you choose not to be vaccinated, well, then you're also choosing to not participate in certain parts of society, right? To me, that means you're choosing to not send your kids to a public school, choosing to not get to go to restaurants, right? Like there being consequences to that action from a public health standpoint doesn't bother me. Because like, yeah, that's because you are putting others at risk by that choice. And so like, it's kind of like, whose freedom are we going to value more, and I feel like it's what's the phrase? Your right to swing your fist ends at the tip of my nose. And so I feel like that's the same situation here. You're free to swing your fist over there where you can't harm anyone. You can't do that over here where you can harm people.
I can't. And a lot of people are. I think the excuse about that I hear here is there's not enough time for research. It's only been a few months or years, so it takes hundreds of years for vaccine to be established.
That's, excuse my French, BS, right? One, mRNA vaccines are not new. That's not new technology. That's been around since the 90s. So it's been around for my entire lifetime, right? It's not new. mRNA vaccines are not new science. Like COVID, or a vaccine for that family of viruses is not new. Had already been in the works, right? It got sorry, I don't want to say fast-tracked, but there was suddenly a big need, and so a lot of resources went to that instead of other things, right? And that turns out in science, the thing that slows us down is lack of funding, right? If all of a sudden you have infinite funding, you can get a lot done, right? In a short period of time. So this idea that this is untested is really nonsensical. And
also, I wasn't sure now, but I gave a reason to them why it's a little bit faster. Why I said, well, last time this happened in the 70s or 60s, we had fears that the power of an Apple I computer or like an old IBM computer. Look at 30, 40 years, we've had much better technology resources, So I'm pretty sure in 30, 40 years, our medical technology has improved a little bit too since the 70s.
Yeah, it certainly has. And so the way that technology has improved things is basically the vaccine was ready to go day one, right? The next year was spent doing the normal trials, right? So that's the only part that was fast, was that they were able to figure it out, right? And vaccine technology. So my sister is a pediatrician, so she talks to parents quite a bit who might be a little like concerned, either not because they're necessarily anti-vaxxers, but like anti-vax propaganda is everywhere, and you want to make sure you're doing the right thing for your kid, right? So this is the line that she uses. So I'm leaning on her expertise here. So one, the safest and most effective medical intervention and most well understood medical intervention that exists is vaccines, right? Safest, we most understand the mechanism, it has the least side effects for the biggest benefit. This is even more so than Tylenol, right? So a vaccine is both safer for your child and you, and more effective at what it does than Tylenol, right? So that's, and then, if you think about it, like I think people are bad at understanding risk and different levels of risk, right? Because like, if you're going to go get a vaccine, right, you're going to wake up that day, you're going to eat breakfast, you're going to get in your car, you're going to drive to your doctor's office, you're going to get your vaccine, you're going to drive home or to work or whatever. Well, the part of that day where you engaged in the most risk was when you got in your car, right? And second to that is probably if you were eating alone, right? Like those two behaviors are so much more risky than getting a vaccine is, right? For a normal, healthy adult.
Yes.
Right. So yeah, like people are bad at risk management. And vaccines are, again, so safe.
Yeah, I've heard all the excuses about why they're bad for you, and like I had two say I had an old saying before, and I have a new saying now.
Mm-hmm.
The old saying was, "Well, I'd rather have autism than polio."
Yeah,
vaccines give you autism. Apparently,
no, that's never been any truth to that.
I know,
that's
but
never been connected.
I'd rather have that than polio and measles.
Yeah, it does speak things that people are more concerned with their child. Like, if you think that autism can come from a vaccine, right? Which it can't. That's not what happens. It's not real. That's not real life. Can't do it. It's definitely very ableist to think that you would rather risk your child dying than risk your child having a disability.
But I think the new one is, I'd rather have that microchip in my arm than a tube down my throat.
Yeah. Yeah, and also there does not exist technology that can make a microchip that fits inside a vaccine that is powered and can do things, right? That doesn't exist.
As far as you know.
No, I know. Like,
I know. I was just joking.
Yeah, like if you think about like the chip you put in like your dog, right? That's not powered. It's just a little. It's a barcode, right? That's it. It's just a barcode that's like under the skin that a barcode reader can read, right? It's not a transmitter. It doesn't do anything. You can't actually track your dog if they're chipped, right? It's just an ID tag that they can't lose.
So in case the pound does find it, they know whose dog it is.
Exactly. But like what people are proposing is going in vaccines is like a microchip that's going to transmit information about you and your location like constantly to the government. Like that thing has to, one, you can't make it so small you can't see it, right? That technology doesn't exist. And two, we don't have anything that can have an indefinite power source, right?
And that had to be like cellular or even virus size for that to be that small in your bloodstream.
Right. And so we can't make a transmitter that small. We can't make a battery that small. We can't, right? Like that, yeah, this like cool sci-fi novel, bro, but that doesn't exist.
So are you saying the non-existent graphic of my vaccine doesn't boost my 5G signal?
It's not boosting your 5G signal. I'm sorry.
But yeah, like I said, I've been like really, and like I said, some of the people I went to school with are believing this. Stuff. You still like people you used to know are like really like you didn't know this about them, like what really?
They've gone down some intense rabbit holes. I know. Yeah, there's a few people that I just blocked on Facebook because I'm like, ooh, no, I don't need to engage with that.
I know, like I said, there says I'm not an anti-vaxxer. I'm a new anti-vaxxer.
No, that's means. The same thing. Like, yeah. Well, and that's the thing. Like, if someone has legitimate questions or concerns, right, or just like there's all this information out there and it's contradicting each other, right? And like I don't know how to tell who's telling the truth, right?
Yes.
If that person like had honest questions, you know what I mean, and honestly wanted to know, right? I am more than happy to talk to them. But for the most part, it seems like people are like, no, this is what I think, and you can't change my mind. Yeah. And if you don't believe what I believe, then you're sheeple. And there's no honest discourse there. And so, like, frankly, it's kind of like how I approach most younger creationism, which is, it's not really worth my time. I don't do edited videos on younger creationism. I only do live streams because it's not worth my time to take more seriously than that.
And unfortunately, most of the time, those two are the same groups of people. Not always, but...
Well, it is true, I think. Don't want to speak outside my field, but I'm pretty sure I've seen the study that talks about, like, if you fall for, like, one conspiracy theory, you're more likely to fall for another. And it just has to do with kind of, like, mindset, I think. And again, like... I don't want people to be tricked, right? That makes me sad. I don't want that for anyone. And so I don't like that people are being duped into believing this kind of stuff. I have to say that, like, I'm not really mad at the people who have been taken advantage of and duped. But I do get mad at people who like actively spread the misinformation, right? And especially who knowingly spread misinformation. And I do try to differentiate those two groups because there are some people who have just legitimately been duped, right? They've been, you know, this has been a very, very stressful couple years for literally everyone. And stress brings out the worst in all of us, right? And it makes us do weird things. you know? And maybe if you're lucky, the weirdest thing you did was, I don't know, what's the weirdest thing I've done in the last 2 years? I've started like sewing my own clothes and learned how to bake bread. And
is it good bread?
I mean, I think it's good. I've taken on some weird hobbies, right? You know, like, but we've all done some weird. We've all made some weird Amazon purchases in the last 2 years, right? But everyone's going to express that like stress and anger. And, you know, I remember like I was getting some like afraid to leave my house-ness. You know what I mean? Some like pandemic induced agoraphobia. That was kind of intense before I got vaccinated, you know?
Yeah, I was like agoraphobia, but I was kind of, I have kind of like, not really, but as a kid, I kind of ADHD. I couldn't sit still for very long. So had to sit still in your house for forever and ever. It's like,
well, and so like, and I know for me, when I go through something like really stressful or really difficult, I tend to process that like very internally, right? Like if I'm going to be randomly like it's going to make me more generally anxious, right? That's a thing that's going to be internal. But not all people are like that. Some people express that externally, right? And so feeling anger, right, and fear and these big emotions at, you know, being under constant threat of a virus for 2 years. You know, I can understand that some people are going to express that in like inappropriate ways, you know? And that's going to be, well, I'm mad, and so I have to be mad at someone, and so I guess I'm mad at the government, you know? Like, because who else can you point to? Because there's no villain here, right? There's just a freak of evolution, a freak of nature.
Yeah. Also, another thing about the vaccine and evolution, you know, that's what it's funny when you mentioned that, and they mentioned that, you know, the fact that they're white, some of them are YC, you know, it's funny that they say, oh, my body will handle it, you know, my body can handle it, I'm strong enough. You know that if I survive, that's great. You know that's natural selection. So letting your body handle stuff like that and pass it on.
Mm-hmm. Yeah.
Stuff they don't believe in.
Yep. Yeah. There's some real, like, self-aware wolves kind of behavior that goes on there. You know, you want to think about that for one more second? You want to, no, we're not going to get the internal reflection. Yeah, so close.
But yeah, I think, I don't know for me, the thing that affected the pandemic the most for me was my new niece. She was born in January, and the pandemic hit in March. So I didn't even get to meet her in person until August of last year. So a year. So for the first 18 months, all we had was Facebook or FaceTime talkings.
Yeah.
And so then I only got to meet her because I was fully vaccinated, not boosted yet, but I was fully vaccinated. So I got to go to see her.
Yeah.
Because when they came over for Christmas, they didn't go to their one side of the family because somebody was unvaccinated on that side of the family. Like, nope, not going visiting them.
Yeah.
That's why I got to meet my niece because I was vaccinated.
Yeah. That's like good on, is it your sister whose kid that is? Or your brother?
Well, my sister's granddaughter.
Okay. So, but good on them, right? Good on that family, your niece's family, for setting some appropriate boundaries, you know, to protect their child who is too young to be vaccinated. You know, and you know, no one's enjoying this, right? We're all very tired of it. But unfortunately, like of course, I am fully vaxxed and boosted. As soon as I could get the vaccine, I did. If I need another booster shot anytime in the future, I'm more than happy to do that. If we need to do a yearly COVID and flu shot day, right? More than happy to do that.
I think it's about, I'm looking like that, the way it's mutating, let's keep on mutating. Hopefully the mutations will end soon, but you never know. But
Yeah,
it might not be a one and done like polio or measles or smallpox. It might be more like a
exactly.
flu thing.
Exactly. Yeah. So different viruses are able to mutate at different rates. I'm not an epidemiologist or a biologist. I don't know how all that works. But there's a reason you have to get a flu vaccine every year, because it mutates that fast. So it might be like that with COVID. But you know what? Give me a vaccine. I love them. They're great.
Yeah.
But what's very frustrating is that the people who can have a positive impact at this juncture, at slowing down the virus's mutation rate, and all of that, are the unvaccinated. And so that's a little frustrating, because we need the people who are like the most hesitant to now be vaccinated, because they have the ability to have the greatest effect on public health at this point.
Yeah, some people's body. I'm not sure, but some people's like people that said their bodies starting to take it. Well, good for them. Most people's bodies aren't starting to take it.
Right.
I have asthma, so I'm not even taking any chances with this thing.
Exactly. So again, I'm vaxxed and boosted, and I still got it about a month ago.
But
and
yeah, so was my other niece. But yeah, like I said, it wasn't as bad as 2 weeks in the hospital. That can't do anything. It was like maybe a little mild case of going home for a day or two.
Yeah. Well, and that was, I have asthma too, and but I haven't needed an inhaler in years, right? Nope. I needed that inhaler, right? And so I can't even imagine how much worse that would have been, right? I probably would have ended up in the hospital if it was full force, because I was taking my inhaler like every 4 hours just to keep breathing normal for several days. So I can't imagine if I hadn't been boosted, if I had gotten the full force of that. And I'm a relatively young, healthy person, but so you just don't know, and yeah, some people get it and it's like a cold, and some people get it and die, and there's not a lot of difference between those two people on the surface.
And also it's like this 1% that like it's only killing 1% of the population. That's no big deal. 1% of 6 billion people is like 600,000 people. That's a lot of people, or 6,000 people. Maybe the math's wrong.
Yeah, 1% of 6 billion is 10% would be 600 million. It's like 60 million people.
Yeah, that's still a lot of people.
Yeah, that's 60 million people, right? That's like
1% of people. That's not that very many. 60 million people is like the size of New York or something.
Yeah,
New York.
It's bigger than that. So and just think about the supply shortages we're seeing now. That's related to COVID, and again, even if you think your body can handle it, that doesn't matter, right? Because if you get it, right, that's still carrying and spreading the disease, and that's allowing for it to mutate, right? That's allowing, so the more the disease is out there, the more it's able to mutate. So get the vaccine to stop it from mutating, or to slow the mutation rate, right? So that we don't have to get a booster every year. But
yeah, also I had Dan on for my last year talking about this too, and talking about how viruses don't want to kill you. If viruses killing you is a bad thing because they can't spread then.
Right. Yeah. Yeah. So Dan from Creationism is amazing, and he does squishy science, which is what I refer to, science involving living things. I don't do the squishy science, so I'm definitely speaking about virology here as a very much a layperson. So yeah, check out that interview with Dan then. Yeah. Definitely has more. He's who I go to for my latest virus updates.
Yeah, but yeah, so what's the newest in your study? What's the newest thing that you've discovered in your study about your field?
The coolest thing I've discovered?
Or the newest thing?
The newest thing. Okay. So, the newest thing is, so there's a specific type of sea ice loss event that's called a very rapid sea ice loss event. Getting that term into the literature is the goal of that paper that I need my co-author to get back to me on. But a very rapid sea ice loss event is when you lose lots of sea ice in a short amount of time. And so the coolest thing that I've discovered is that when you have that type of sea ice loss event, there exists a very strong pressure gradient centered on the ice loss at the surface. So strong pressure gradient means really strong surface winds. That pressure gradient is then associated with a large storm, a surface cyclone. And so that was like my whole master's thesis, was just like establishing that those things are true. And so that was really cool to get to do that. That's like such a great great result, right? I have this result and it's robust and I can show it in this plot and I can show it another way in this plot and it's a thing, right? That's new. And so that was really exciting. And then what's really fun is, so then the question is, okay, so we know that there's a strong pressure gradient, so there's strong winds. And so there's kind of two leading theories as to what mechanism causes the sea ice loss. One is that that strong pressure gradient is bringing warm air up from the south, right? Warm air melts things. And then the other idea is that strong pressure gradient induces strong surface winds, which induces ocean waves. And then those ocean waves go into the ice and smash it. And then smashed ice melts much faster and easier, and is easier to move around. And then that's what's going on. So I'm working on figuring out which of those two processes is most important. And I'm also comparing the types of like signals in the data that we get in like real data versus what we get in climate model data, because if it's that mechanical effect that I described, then it looks like that type of process is missing in the climate models. And so in theory, introducing that mechanic into a climate model would help improve a lot of climate models. So that makes me feel really happy that I might have figured out a way to help improve climate models.
Nice.
And how they capture Arctic sea ice.
So are icebergs sea ice or fresh ice?
That's usually fresh ice. So that's an iceberg is usually something that's broken off from a glacier.
Okay. So no Titanic hitting sea icebergs then?
No. That would sea ice really only exists like in the Arctic Ocean.
Okay.
Once it moves, it's not really deep, right? So icebergs can be, really, really, really deep. But sea ice tends to not be. I mean, it can be like feet deep, but not like destroy a ship deep. And so it melts pretty quick once it gets out of the Arctic.
I think that's all I can think of as questions for your topic. Are you going to be so are you at level? Have you peer reviewed anybody's papers yet? Your papers are being reviewed now, but vice versa. Have you get to review anybody's papers?
No. I did recently join a committee, so I should get to start reviewing some papers soon. So generally the way it works is like once you have submitted a paper to a journal, you're now on that journal's list of potential reviewers, right?
Okay.
So if you haven't actually, like if the editor has never gotten your paper in hand, then your name isn't on the list of reviewers.
But you haven't yet reviewed other people's papers?
Correct. Yeah, correct.
Check your work on theirs.
Yeah. I mean, I've done that for some of my like friends and peers in grad school, but that's not a formal process. That's just being a good friend.
Okay. So what's your name of your journal? What journal did you be in again?
There's several.
Okay.
I guess I have gotten something into BAM's bulletin of bulletin of the American Meteorological Society. They published a summary of a presentation I gave at a conference a couple of years ago. But that's a less formal process.
Okay.
So there's the Journal of Climate is a big one. The anything from the American Meteorological Society. So there's there's not a specific polar journal that I can think of off the top of my head, but sometimes there might be a special issue of a journal that focuses on climate.
So have you come up with your own hypothesis or theory yet named after you yet?
No, nothing named after me.
So no three evolution or germ theory or gravity theory yet?
No.
People in 100 years were saying this was Maddie's came up with this theory.
Yeah, Maddie's theory. No, that'd be super cool, but I don't have anything like that named after me.
The theory of sea ice.
Yeah, the theory of sea ice.
That's another thing. That thing we talked about with I forget with Jackson Weed and Tony Reed about how the processes of hypothesis to theory and laws, they're not the same thing, and some people don't realize that.
Yeah. So there's very few laws. And laws are generally mathematical expressions that are universally true. So
everyone knows that theory becomes a law when the Congress signs it and the president signs it in the law, right?
No, that's not how that works. So Newton's second law, right? Force is equal to usually you see it written as mass times acceleration, but that's actually a simplification of the full law. It's actually the time derivative of mass times velocity. But anyway, that's a law. But I don't know, I feel like in your high school science class, you're taught this list of laws, you're just supposed to memorize them, and that's just not how science really works, right?
True. It's complicated.
It's complicated. Yeah, and the way when you're a kid, I think when you think about who a scientist is and what a scientist does, I think you think of them as a dude, or a gal, a person. You think of them as a person that they probably wear a lab coat and they go away by themselves for a long time and they think about something really hard and then they come back and do some math, and then we know how gravity works, right? And that's very far from the truth, because in reality, science is an incredibly collaborative process.
Yeah, exactly. I was talking about earlier about my geocentric episode.
Yeah.
We're talking about how different theories are built upon each other. First there was Copernicus, and then Galileo, then Einstein, and then Newton, then Einstein. They kept them bleeding up on top of each other. Take that theory, find what's wrong with it, make a new theory, and science goes on.
Yeah. Well, and if you even think about that, Einstein wasn't working by himself, other people were working on similar things. He was just sort of the first one to put that all together.
Yeah.
Right. So, and some also perfect really important science can be something like I run a lab and I measure the heat capacity of different materials, right? I'm never going to get a law named after me, right? But everyone on planet Earth is going to use that data that my lab came up with, right? Yeah. And so you can't do science in a vacuum. You can't do it alone because there's just too much to know.
And plus, things affecting you never know, but the thing across the Earth might be affecting your thing you're having now, like when Newton was doing Darwin
Yeah.
that was doing evolution across a few miles away. I can't remember these guys' names now. Mendel was doing the genetics
yeah.
things, and you would think
Yeah.
that it would match up, but then later on, the two things matched up.
Right. And so, like, imagine if it was in the modern world and those two guys were going to the same conference, right? Like, that's one of the reasons science can advance as quickly as it does now. But again, it's important to remember that, like, while we remember the names of specific people, we are also forgetting the names of a lot more people who were doing supportive work, right?
Yeah,
or maybe, like, sometimes it comes down to luck, right?
Yes.
What if I did the experiment that, what if Mendel and I were buddies and okay, you designed this experiment and I'll design this experiment, and then we'll compare results. And my experiment gets negative results and his experiment gets positive results, right? My experiment is no less important, right? And we didn't know ahead of time who was going to be right.
Yeah, or vice versa. But he takes the credit. It's like back in the 1800s, and you can't be a scientist. You're a girl in this game.
Yeah, no. I also have this. I've been under the weather the entire month of January, so I haven't had new content on my channel for a while. But I started doing a series of scientists you should have heard of, which features lots of very cool scientists that did lots of very cool things throughout history. That you're typically never taught about. So one of my favorites is this. There was a whole order of nuns that did astronomy.
Ooh, nice.
Right. So, like, stuff like, women have been doing science forever. They just haven't been credited for
I think my favorite one I've heard about in the past is that paleontologist girl that found the Ichthyosaurus and all those fossils, when she was a little girl. And
oh, shoot. Yes, I know who you're talking about, and I'm kicking myself because I can't remember her name right now.
That didn't get credit for it until like 12 years ago or something, like very recently.
Yeah. There's also a very special club for, like, women for whom men won Nobel Prizes for their work. Rosalind Franklin, Lise Meitner. There's a Chinese woman who, before I do a video on her, I'm going to sit down and practice my Chinese pronunciation of her name. So I'm not going to try it now. There's other ones. I just can't think of them off the top of my head. But yeah.
So what's coming up on your channel besides that? Is that anything else coming up on your channel?
Yeah, so hopefully I can get back to making some videos this week and get caught up on some stuff. So I've been doing a series on Weather 101. So if you just want to, this is like, they're little 5-minute episodes that just cover one little topic. And this is kind of how I would teach a intro to weather class to freshmen, sophomores in college. Or if I had to say in how I structured my classes, this is how I would teach it. And so we've just gotten through the first law of thermodynamics in that. And now we're going to start looking at vertical profiles of the atmosphere, something that's called a skew-T diagram. It's a thermodynamic diagram, picture of the atmosphere, and you can use it, just a single column, to do a lot of weather forecasting to get an idea of what things are going to be. So we're going to get into actually starting to do a little, like, learning some forecasting tools just by looking at a vertical profile. So we finally learned all of the thermodynamics we need to do that. So getting into those is coming up on my channel. And then I'm thinking for my next live stream, I really want to review that Jordan Peterson, Joe Rogan conversation about climate change. Because I don't like either of them, and I don't like climate misinformation.
Yes. And so can you put the link that you're going to be on in about a half hour in the description?
I don't have a link to it, but I'm going to be on Almost a Doctor's channel. We're going to be doing some live debunking of bad 5G info.
Oh, cool. I was just talking with him yesterday morning.
Yeah.
On the Heretics channel, Heretics live channel. We were talking with him. So I know who that guy is.
Yeah, he's a good guy. He's been a guest on my channel several times. He pops up and helps me do some live debunking. I love doing live debunking with friends. It makes it more tolerable.
Yeah. Hey, speaking of that, if you feel free to mirror this video if you want to on your channel.
Okay, great. Thank you.
I won't copyright strike you at all.
Appreciate it.
Yeah. Well, for me, I haven't anything planned coming up. This was the last of my planned live streams, but I have a few ideas coming up. I'm working on with Venerable Bede. Me and him are planning to, in the future, do a episode on Henry VII.
Excellent.
And his wife Elizabeth of York.
Okay.
The Roses. I'm also planning to do with RJ and Brainbug, maybe Jackson, about the evolution of different wings and species of insect wings, pterodactyl wings, bird wings, bat wings, and Pegasus wings.
Very cool.
Yeah, and then I've also want to talk to this other YouTuber. We're going to talk about Dragon Ball Z.
Excellent.
Yes, I have lots of different topics on my channel. It's all variety. So
that's awesome.
Before we go, do you have a catchphrase you say at the end of your shows?
No, not normally.
No catchphrases?
No.
You should get a catchphrase.
I usually say something to the effect of, okay, team, that's all I've got for you today. I hope you like this video, and I'll see you all in the next one.
Nice. I say, never stop learning and enjoy the randomness. I'll see you then.